Ladies and gentlemen, welcome to the Technical Forum of Hydrogen and Fuel Cells Europe. My name is Bernhard Dekel. I'm the moderator here. Sometimes I tell this for the people who are new here. And also welcome to the online visitors. We have lots of people looking via internet and via stream. So we are not alone here. Maybe there are a few hundreds watching this. And we have lots of great presentation of the newest technology. There was a lack of time, and now we have lots of the cutting-edge presenters. And now we've got the subject PEM electrolysis on a gigawatt scale, sustainable use of Iridium. And we got the manager of Research and Development Hydrogen Systems of Heraeus, that's my hometown, Dr. Christian Gebauer. Welcome.
Thank you very much. Welcome also from my side. It's a pleasure to be here. And as already introduced, we want to show you our view on PEM electrolysis, especially with a focus on the hot topic of iridium scarcity. I will make a very, very brief introduction of Heraeus, a very short one, going directly afterwards on topic. As you can see here, Heraeus is a family-owned company, still a family-owned company with a very rich history. Therefore, many so-called global business units, many applications are in our portfolio. And one of the main ones is precious metal-based materials. And here, the precious metal global business unit is the one where we had our hydrogen systems, our hydrogen application. Now I will show you what it's about. And maybe for most of you, very, very familiar, but all the catalysis or many of the catalytic reactions taking place in the hydrogen economy are based on precious metals. As you can see here, that's beginning on the hydrogen generation. It's ending at the hydrogen conversion or hydrogen application in the fuel cell. But also in between, there are many steps where you need precious metals for purification, for conversion into molecules to transport them. So a very important topic. But that means at the same time that we have to use all these materials as a resource very sustainable way. Therefore, we have a strong suit also in metal management and recycling. And this can be seen here in what we are offering directly for our hydrogen application. That meaning we offering products with low and most efficient use of precious metals, highly stable materials for long-term use. Second thing I already said for sustainable use is recycling. And also maybe familiar to most of you, precious metals are precious because they are scarce and they are a bit more expensive. So these volatilities you see in the market is something where we can also help that the stress as the customers are disappearing. But to look why we're talking about this topic, precious metals and hydrogen, we have to start with hydrogen generation. And there are many, many different ways to generate hydrogen in an electrolysis. And we summarize this in a very nice graph, which is coming from a study from the IEA. And you can see that we have already 50 gigawatts of capacity announced for the water electrolysis, for the water splitting, for hydrogen generation. And if we look at the roadmap from Europe, where we talk about 40 gigawatts in 2030, you see that a lot is coming. And what we see at this moment at the market, as well as future studies showing that the share of PEM electrolysis due to its benefits is increasing. So that means that the use or the need of precious metals is also increasing. One very important thing on electrolysis, PEM electrolysis, is that's not only using platinum, a very common precious metal, but also iridium, which has a certain scarcity in the market. You see it here on the left-hand side, the whole market, supply market per year is only 8 to 10 tons. And if we look now on the graph on the right-hand side, with the current use of iridium in an electrolyzer, we will soon come to a point where the supply or the extra supply of iridium could be difficult. So we are targeting to go to a point where systems are reaching a range of application where the PEM electrolyzer, or better said, iridium, will not be a showstopper. And if we look away from a material innovation, what we are doing mainly, there are also very much effort going on in component interplay of system optimization. So the target range you often find in studies is really reachable. And I will, of course, have a short look with you on material innovation, what we are doing. Maybe quite short in a summary, there are benefits for PEM, therefore we believe in PEM. You see it on the left-hand side. There are challenges, well-known challenges, but as I said, there are many mitigation strategies, and we try to offer all these mitigation strategies and try also to alter the materials in combination with all the components. And this is shown here. It's a summary of our materials, a full metal material, so-called iridium black, and iridium dioxide, which is already a further generation down the road, and finally also a supported material. And as you can see here, depending on the application, we offer all three because they have the best performance or best application in processability, interplay, and activity, as well as stability in different applications. So we try to get for the customer the best fit. However, and that's something we have to emphasize, if we want to go to the target range of loading and use of iridium, at a certain point only supported material will be the right way. And we were lucky, we were part of a nice project called Copernicus Power to X, and we had the chance to challenge our material against the benchmark. And as you can see here, with our supported materials, we create really superior mass activity. Often, you know, high activity is going hand in hand with low stability, luckily, and therefore the materials were developed in this direction. That's not the case. And a most recent study, this should be online next week, you can see that it's the long-term stability in a short stack was proven over more than 5,000 hours, showing that this mass activity or this superior performance can be maintained all the time. So, material innovation is going to the right direction. As I said, components are important, but also the last step, the recycling, is a very, very important point to talk about sustainable use of precious metals, and here especially about iridium. And as you can see here, this is already a big business. Second supply or secondary metals are very important already today, not only from the use that you have the material, but also from a carbon footprint. So the sustainable use of precious metals is really something which is going on, which is going in the right direction. And as you can see here from the numbers, it's already also a big business in our house, and it's going on. Of course, for the hydrogen economy, that's getting a bit more complicated, or let's say challenging. There are new material waste streams we have to deal with. Fluorine is one important factor we have to see here, but also the way how the material is coming back to us. And you see it here in a very easy way. We are working, of course, in the first step, but we're trying to not to lose the chain until the end of the end user, and in the end, over a collector, a dealer shop, some dismantle of this material coming back to us, and we can get back the material and this whole value back to the market. So let me shortly summarize, and I will not read everything what is written here, but the main things are: there is a sustainable use possible and also necessary if we want to have a good future for PEM electrolysis, and we see it from material innovation, from component interplay, and last but not least, very important, from a recycling strategy which has to be implemented from the beginning on. And since I showed some slides or some numbers which are not originated from us, a short disclaimer, and I thank you very much, and I welcome you at our booth. You see it directly, our sign is, if you turn around, you see it directly, so please come there, talk to our colleagues, and we were happy to answer your questions.
Wow, great. I'll stay here for a moment. Thanks a lot, Christian Gebauer. Is there any question? Any question from the audience right now? Now the chance to have one question here.
If not, you're welcome. Please come over and we have a chat.
Okay, thanks a lot. Dr. Christian Gebauer.
Thanks so much.